Good morning, chemistry cats. I hope you're all doing well right now. Today we're going to talk about different types of solutions. Now, just a reminder, a solution is a homogeneous mixture, and usually the mixture is a solute dissolved in water, water being the universal solvent, or as I like to say, the GOAT solvent, greatest of all time. So all three of our solutions today we can assume are dissolved in water, therefore an aqueous solution. Now, because they're all solutions and they're all homogeneous mixtures, they all three look the same. So all three look like water. Like you have something dissolved in water, but let's say we weren't there to make it. We don't know how much there is. We're going to find out today how to tell the difference between an unsaturated, a saturated, and a supersaturated solution. So we're going to start out with our unsaturated solution. Unsaturated means that the solution contains less than the maximum amount of dissolved solute at any given temperature. So we haven't reached the maximum yet. So if I were to take a piece of solute and plop it into my unsaturated solution. So here's some solute, I'm going to drop it in. And if I stir it around enough, because we haven't hit the maximum yet, when I add that crystal of solute, it's going to dissolve. So it will dissolve and become still a homogeneous mixture. So in here, for our unsaturated solution, additional solute will dissolve because we haven't hit that max yet. I'm going to move this over a little bit. So when I drop that in, it's going to dissolve, and then I still see the same thing. It's still a nice homogeneous mixture where everything is fully dissolved. All of my solute is dissolved. All right, so our second solution is called a saturated solution, and saturated solutions contain the maximum amount of dissolved solute at a given temperature. So we're going to assume that all three of these solutions right here are all at the same temperature, let's say room temperature, about 21 degrees Celsius. The saturated solution already has the maximum amount of solute that can dissolve. So let's see what happens when we plop in another crystal of solute. So let's say right here, here's my additional crystal, adding solute in. Dun, 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 dun. Since we've hit the maximum amount, this solute that we add in cannot dissolve, so it's just going to settle at the bottom. It is still a solid. So when I try to add more, cannot dissolve anymore because we're already at the max. So my additional solute settles at the bottom. And it stays solid. Now, some of this solid will dissolve, and some of the solute that is dissolved will recrystallize. So this is what we're going to call a solution equilibrium here. So in my saturated solution, I have a little bit of solid dissolving and a little bit of dissolved solute recrystallizing on the surface here. And that's what we call a solution equilibrium. And I'm going to go back, try and get my box back. That's not working. Sorry, ChemCats, technical difficulties. My bad. Luckily, it's only you guys watching. So I have a little bit of my solid will dissolve, and then a little bit of my already dissolved crystals will recrystallize and solidify on my surface right there. So I add my text box back in here. It's back. So my saturated solution, we already have the max amount dissolved in that solution. Any extra or additional solute will settle at the bottom, and then at the bottom we'll have that solution equilibrium. Whoop! Beautiful. Okay. That was a good recovery on my part. Glad you guys can watch me. Okay, so that's my saturated solution. I already had the max dissolved, and now we cannot get any more to dissolve at this temperature. Okay, last one, my super saturated solution. These are the coolest. They are the hardest to make, really rare and difficult to make. These are the types of solutions that people will make when they're trying to make rock candy. And I don't know if any of you guys have tried that at home, but it's like that candy that looks like little crystals. It's tons and tons of sugar that you've dissolved in water. It's also the type of solution that they use to make lollipops or pops or suckers or whatever people call them. All right, so we're gonna have a super saturated solution right here, which contains more than the maximum amount that should be dissolved at a given temperature. Now when I have my super saturated solution, I'm going to see what happens when I plop a little bit of extra solute here. So I'm going to take my crystal and we're going to drop it in. Dun, dun, dun. And super saturated solutions are very sensitive. So as soon as this crystal hits the surface, the whole solution is going to start to recrystallize. And all of that solute that had been dissolved is now going to become solid again. And it looks kind of like frost or like a freeze almost. And all of it just like expands out and recrystallizes as soon as that solute hits. It's pretty crazy. So my super saturated solution has more than the amount that could already be dissolved. So the whole thing will recrystallize. So as soon as that contact happens there, the whole thing recrystallizes and refreezes out. It's pretty cool to watch. That is all for today. Thanks for tagging along here. Appreciate it. Thanks for holding in when my difficulties were happening. These are my 3 types of solutions and what happens when you experimentally test the difference between them. So this would be something that you could do in lab, especially if you don't know if a solution is fully saturated or not. So if you need a solution to be saturated, you can test to see if it is or if it's still unsaturated by just adding a little crystal more of solute. All right, have a great day. See you later, ChemCats.